for these set of problems, we're going to be looking at interpreting normally distributed data. So this is actually going to require us to create this image that we have here, where we have to create or figure out what our mean is and what these values are by adding or subtracting the standard deviation. And so something I just want to note here before we go into that problem is that each time when we're going to the left, we are subtracting a sigma each time. So to get from mu minus sigma to mu minus 2 sigma, I am subtracting, where over here I am adding my standard deviation each time. So it's important to note before we do this problem. Okay, so number 1 says the scores for a state's peace officer standards and training test are normally distributed with a mean of 55 and a standard deviation of 12. The scores range from 0 to 100. About what percent of the people taking the test have scores between 43 and 67? So this is going to be just like what we did in the previous problems, but now I need to figure out what these numbers are down here. So I know in the middle is my mean, my mu, and so I see here that it tells me that my mean is 55. So that's going to be the middle. To get the numbers on the left and the right, I need to add or subtract my standard deviation. And so it says my standard deviation is 12. So to get the numbers on the left, I want to subtract 12 each time. So 55 minus 12, I get 43. 43 minus 12, I get 31. And then 31 minus 12, I get 19. Now to get to the numbers on the right, I'm going to add 12 each time. So 55 plus 12, I get 67. 67 plus 12, I get 79. And 79 plus 12, I get 91. I'm going to go ahead and write these numbers on this graph below here as well, since we'll use it for this one too. So this first problem asks us to find about what percent of the people taking the test have scores between 43 and 67. So I see my 43 and my 67. I want to find the number or the percent between. So that's going to be this area right here. And so it's going to be helpful again to look at that graphic we had on the first page. And I see for those two areas that it corresponds with my 34%. So that means that this probability is going to be 34% plus 34%, which is equal to 68%. Part B says, an agency in the state will only hire applicants with test scores of 67 or greater. About what percent of the people have test scores that make them eligible to be hired by the agency? So here we're looking at test scores of 67 or greater. So we're looking at the probability that X is greater than or equal to 67. So I want to see 67 here, and I want all scores greater than it. Going to be everything over here. And so looking up here, that's going to correspond to the 13.5%, 2.35%, and 0.15%. So if I add all those up, so I have 13.5% plus 2.35% plus 0.15%, I get that this comes out to be 16%. Okay, let's look at one more. Here it says the SAT is designed so that scores are normally distributed with a mean of 500 and a standard deviation of 100. Normally distributed, so we can go ahead and do what we talked about before. So I want to first go ahead and create my graphs. First, I need to recognize what my mean is, and it tells me my mean is 500. So it's going to be my middle value for each of these. And then it says a standard deviation of 100. So that means I'm going to be adding or subtracting 100 each time to get my numbers to the left and right. To the left, I'm going to subtract 100 each time. So that gets me 400, 300, 200. And then I'm going to add the 100 each time. So I get 600, 700, and 800. And I'm going to copy those on my other two graphs. Okay, so number part A says about what percent of SAT scores are between 400 and 600. So I see there's my 400, my 600. So it's everything in here. And so going back to my other graphic, I see that those two are my 34%. So this is going to be 34% plus 34%, which is equal to 68%. Okay, next it asks what is the probability that an SAT score is above 600. So I'm going to look at everything greater than or equal to 600. And so that's going to be everything here. And so that corresponds to, again, that 13.5% plus 2.35% plus 0.15%, which is equal to 16%. Okay, and then the last one says, what is the probability that an SAT score is at most 300? So here, keyword or words is at most. So that means that I'm looking at less than or equal to 300. And so I want to go to 300. It's right here. So I'm looking at everything less than or equal to that. So it's going to be 2.35%. Let me see in that graphic up here that those last two are 2.35% and 0.15%. And when you add those, you get 2.5%.